Hello everyone, welcome to QHSC Concepts Welding and NDT channel. Today we'll take a look at CSWIP 3.1 Chapter 11, Section 11, Manual Metal Arc, Shielded Metal Arc Welding, which is SMAW. We always call this as SMAW, but in American terms it is called MMAW. So this is the two difference that everyone must know. So let's proceed on this chapter. Must not be very big, but we'll still try to make it as much as information packed as possible. So manual metal arc or SMAW was invented in Russia way back in 1888. So you must know that it is a very invention is around 30 to 40 years before the First World War, and involved a bare metal rod with no flux coating to give protective gas shielding. So, when we really started this invention, they just took the piece of metal and then struck a cord by using a high current voltage machine. At that time, they didn't know what exactly they are doing. So, exactly this is just how it started. Later on, they came to know that the shielding is required. Otherwise, in the welding, there is a lot of defects coming. That also they came to know when they made a lot of things and tried to break it. That time they saw that it is a lot of inside there is a lot of flaws, defects. So later on they added the coating, which then got the gas shielding, or let's say they got some kind of protective shielding. So coated metal electrodes weren't developed until early 1900s. So you can understand that early 1900s is when Einstein was writing his papers. So till that time, electrodes were not really there. They were just first 20 years, they were just welding without any protective coating. So when Kilberg process was invented in Sweden, and that's why we see that Sweden is so ahead in this welding technology, and many companies like ISAB and all are Swedish companies, and they are very good in welding technology, because they almost invented this whole process, and that is the reason. So, and the quasi-arc method was introduced in UK. The quasi-arc method is what is the famous arc welding technology that we are using. Most versatile welding process, MMAW, is suitable for most ferrous and non-ferrous metals. Just let me 1 second check whether we are doing recording or not. Yeah. Okay, let's proceed. So, the most versatile welding process, MAW, is suitable for most ferrous and non-ferrous over a wide range of thickness, can be used in all positions with reasonable ease of use and relatively economically. So, as you know, SMAW process is so versatile, it is almost used everywhere. Only thing is, whoever wants the productivity to be higher, they will go with SAW, or they will go with FCAW, GMAW, this kind of process. As we have seen in the earlier chapter, the efficiency factor for SMAW is half of that of SAW. That is why this is not preferred method. So if you have hundreds of welders, you will go for semi-automatic or automatic machines. So this one, everyone needs to understand this. The final weld quality is primarily dependent on skill of the welder. Of course, whatever process you use, skill of the welder is very important, and that's why this field is very difficult to automate. Almost automation has already started, but even today, I think next 10 years, skill of the welder is going to be important. But this is not forever. The automatic machines are already catching up. On LinkedIn, I am already seeing the automated machines have started welding. So when an arc is struck between the coated electrode and the workpiece, both surfaces melt to form weld pool. Basically, what you're doing is when your welding machine is on, you have an open circuit voltage machine. So the voltage is already high there. It's about 80 to 90 volts. And all you need to do is bring the electrode closer to the steel, and it will make a circuit close, and then that time it will have arc strike. Because the circuit is trying to close, and that's why the arc is striking, and then using this simple electric method. For electronics, we are doing this physics. Using this physics, we are using this process to weld and melt both the electrode also and the steel also, and that's why it is called as fusion welding, because we are trying to fuse two steel plates together by using a steel electrode. So an average temperature of the arc is approximately 6,000 degrees. So when the arc will strike, temperature is as hot as sun. So you have to understand that it is very hot, sufficient to simultaneously melt the parent metal and consume the core wire and the flux coating. So the electrode will go on consuming and the edges will start melting if the welder's skill is there. By weaving the pattern by the hand, he will make the pattern, which is called weaving pattern. So the flux forms gas and slag, which protects the weld pool from oxygen and nitrogen. So what is happening when we are doing the electric welding or high current welding? If there is no protection, then it is oxidizing, and nitrogen will interact with the welding pool and it will damage the welding. That's why this flux is used. Either it is a coated electrode or you can use CO2 gas or argon gas. So that is forming a part of a protective layer around the arc and trying to protect the arc from oxygen and nitrogen. So surrounding temperature also is important, atmosphere is important, because there may be wind or there may be something like that, but it will protect. So the molten slag solidifies, cools, and must be chipped off when bead once weld run is complete. So naturally the slag has to be removed, and all this while the video is happening, you can see what I am describing. So this is the process of removing and chipping the removing slag, because we don't want this slag, because if we continue to do welding, the slag will get trapped and then it will have defect. So it has to be removed. So the process only allows short length of the weld to be produced before new electrode needs to be inserted. So as you know that electrode has a fixed length, and it has to be once it becomes smaller and smaller and smaller, ultimately only 50 to 70 mm will be left. You need to throw that stub and take a new electrode, and that is why the process is slow. And you know why? What happens every time the electrode need to be changed, the welder may get bored and or let's say fatigued, or he will take the rest, which is not good. That whole thing is removed by FCW welding. You can see with FCW welding, the gun is having a button, and if you press continuously, the electrode is coming. Then people who think about productivity have removed the change of electrode because they saw that productivity is going down because of this constant changing of electrode. So this for diagram will help you understand that this is the base parent material which we want to weld. It may be a plate or a pipe or anything, it may be of steel, and then you can see the welding is already started and come up to here, and here there is an arc. In this arc you already know how hot it is, 6,000 degrees centigrade. So this is the electrode, and then surrounded by that there is a filler metal. So there is a flux coating. This flux coating are various types of flux coating are coming, so that one needs to know. We will learn that in the welding consumable chapter finally. So right now you just note that there is this flux coating is very it's like calcium carbonate, and all these materials are glued together with steel in a machine, and that electrode is made, and then you are using that electrode for welding. So electrode angle is not exactly 90 degrees, but it is tilted slightly 15 degrees to 20 degrees depending on the welder's skill, and it is at 85 to 75 to 80 degrees to the normal, and you are welding there. So the typical welding machine I am showing here to you. So this is the power source, and this is the quiver. Is stored here. Power source just have to make smaller. So item number 1 is called power source. Item number 2 is the holding oven. So this is the holding oven. because many times electrodes are not vacuum packed. There are two types of electrodes available. One is not vacuum packed and one is vacuum packed. So for the vacuum pack, you can directly use in the job. You can see that item number 8 here shown is vacuum pack item. This one. So it doesn't now. It's just a normal electrode. So in normal electrodes, first you need to put it in the mother oven and bake it with 350 degrees or something. You have to bake it, and then you have to put it after 4 to 6 hours. You have to remove it and you have to put it in holding oven. Holding oven is also at a set temperature, and after that you have to keep it for some time, and then you can take it out and use it. And while using also, you just can't use it within your hands. You have to keep it in this quiver. That's why the quiver is shown here. This quiver is connected to 110 volts and it is at constant 80 degrees temperature. And with that only you are doing you're removing the electrode very hot, at least at 80 degrees, 70 to 80 degrees, and then using it. So then only you will have no hydrogen pickup and your welding will be very good quality. So item number 3, inverter power source. So this is again the inverter power source is saying. For electrode holder, so the electrode holder, this is the one. And electrode cable, and the holder cable basically is copper electrode. The winding, it is a very heavy cable because a lot of copper is used in this wire, because we are talking about very high current. So if you want to use very high current, then a lot of copper is used. Then welding visor. By this you will see the welding, because otherwise your eyes will get damaged. Power return cable 7. The return cable is basically going from negative of the machine to the workpiece. Wherever your workpiece is kept for proper grounding, it is required to clamp that. So that is called as also the return cable. 7. The 8 is electrode, of course. 9 is electrode oven. This is the oven, and which is baking the temperature at baking the electrode at 350 degrees. Then the control panel on, off, amperage, polarity, open circuit voltage. So machine which you are going to select for welding should be open circuit voltage, because then it is safe to handle. So more about open circuit voltage, if you want to see, you can go to online and watch the video. Basically there are two types, open circuit voltage and closed circuit voltage. Open circuit voltage means when the machine is not working, it will be at 80 to 90 voltage, and when you strike an arc, that voltage will come down to 25 to 30 volt maximum, and it will be safe to use. That's the reason it is called open circuit voltage. So MMW welding, manual metal arc welding, can be carried out using either DC or AC current. So ये भी एक important मसला है, बहुत लोग confuse हो जाता है इसमें between AC and DC welding. Mostly all the machines are DC machines. Yeah, the power that you going to give that machine is going to be AC power. Well, when you give that AC power, that machine will transfer that into DC, and welding can happen very nicely in DC. But doesn't mean that AC will not do welding. If you use AC welding machines also, it will weld, but there will be some porosity or some kind of spatters will be there that you need to note. And you can also see the video on this AC versus DC. It's very important that welding inspector must know a lot about welding machine and all the items and equipments. So with DC welding, current, either positive or negative polarity, can be used. So current is flowing in one direction. So AC welding current flows from negative to positive and is two directional. So everybody has seen the sine wave. So sine wave, if you already know this, the sine wave, the electrodes or electrons flow from negative, the current flows from negative to positive terminal. Power source For MMW manual welding are transformers which transform AC to suitable for welding. The transformer rectifiers machine is also there, which rectifies AC to DC, which is what I have told you that DC machines are mostly used. So diesel petrol driven generators are also there. So you will see many times when you are going to do cross country pipeline, or you are just driving on the highway, you can see there is welding going on. You will always see a generator there because there is no other power source. So that generator will have a inverter, and then that welding, it will be given to the welding machine power source, and power source is a constant current. Drooping output must be used. What is drooping output we will see in the coming in this coming sections. So the power source must be open circuit voltage. Let me make it a little bigger. To initiate the arc, welding voltage is between 20 to 40 volt to maintain the arc during the welding, and you must see all the WPS, so it is within this range. Suitable current type, typical 30 to 350 amps, the machine should be able to give you. Stable arc, rapid arc recovery, or arc reignition without current surge. That is very important because when you are striking current, this is not a perfect process. A lot of back and forth is happening, and that time there should not be a current surge. So that is a stable rapid arc is required for this, and that is why mostly DC machines are used, because they rectify it very well. So constant welding current, an arc length may change during the welding, but consistent electrode burn-off rate and weld penetration characteristic must be maintained. So the arc length is basically one diameter of electrode. That is how much is the length between the electrode and the workpiece. That length he has to maintain during the welding process without going too close to the steel or going too much away from the steel. Otherwise, what will happen? The electrode, the burning will be a problem, and then it will give you very poor quality welding. So welding variables, the other factors or welding variables which affect final weld quality are current, voltage, travel speed, polarity, and the type of electrode. This everyone must know very well, and you by heart this. What are the variables for welding? Even before the PQR, or let's say welder qualification begins, the main 5 characteristics are current, voltage, which will change the welding issues. It will make you welding issues. Travel speed, how fast or how slow you are traveling. Polarity, if you are using positive or negative electrode. Then the type of electrode, whether it is a 60, 70, 16, 60, 10, whether it is 70, 18 and 80, 18, so on and so forth. So all this affects the heat input. That's the reason it is very important. So current, the flow of electrons through the circuit is welding current measured in amperes. And ampere controls burn-off rate and depth of penetration. Now this is very important for the rest of your life. You have to remember this, that the current is very important because it controls penetration. How easy penetration you will get, it depends on that. That's why many times 70-16 when you are doing root pass, it is put in negative polarity. That is why it will get good penetration. So welding current level is determined by size of electrode and manufacturer recommendation, the normal operating range and current. So naturally the welding current is determined by the electrode size also. But you, as a rule of thumb, and I will tell you only on this channel, no one other channels will give you, if 1 millimeter, if you have 2.5 millimeter of rod, every 1 millimeter you need 45 amperes. So this you remember, 1 millimeter is equal to 45 amperes on a approximate range, 45 to 50. So if you have 2.5, naturally you just have to multiply 2.5 by this figure, then you will arrive at the current which is required. So 2.5 into 45 is almost 112, and so you will need about 110 ampere. And you can cross verify this. Is just a thumb rule, and you can always check this with your welding engineer as well. So what happens if the ampere is too low or high? So if it is too low, poor fusion. If you say you are using 2.5 electrode and you have the current requirement of 110 ampere, but you are having 90 ampere only, then what will happen? There will be poor fusion or penetration, irregular weld bead shape, slag inclusion will be unstable, the arc will be unstable and arc will stumble and then stubble here and there. Then porosity and potential arc strikes will happen. So what will happen? Electrode will not burn properly. It will start, stop, and then you will get a lot of potential arc strikes, because then the electrode will go here and there, and this arc will strike in the parent material also. So what will happen if it is too high? Excessively high, excessive penetration, burn through, undercut, spatter. So these are typically new welders issues. When the welder is new or the machine is new, they are trying to adjust and all this. So excessive penetration means what will happen? The root will burn through and there will be a big hole in that, and then you'll have to have a refit up done. Then you will also have undercurrent, so undercut. So whenever you have root undercut and capping undercut, it is for 100% that it is welded in high current for fast productivity. What happens is usually they are saying to the welder, do welding fast, and then the welder will do higher current and do faster welding. Then undercuts will happen, and during that time spatter, porosity, everything will happen. So deep craters, electrode damage due to overheating, then high deposition making positional welding difficult. So these are all the problems related to high ampere welding, high current welding we call. So coming to voltage, the welding potential or pressure required for current to flow through the circuit is called as voltage, obviously. So the MMW welding technique, the voltage required to initiate the arc is open circuit voltage. So I have already described you what is an open circuit voltage. Voltage measured between the output terminals of the power source when no current is flowing through the welding circuit. So open circuit voltage means the voltage will be around 80, 90 like that, measured from the positive to negative terminal. Positive negative terminal is positive is in the electrode and negative is with the workpiece attached. So there already the voltage will be ready 80, 90 voltage, so that your arc will strike very easily and is also very safe. So for safety reason, OCV should not exceed 90 volt and is usually 50 to 90 volts. So arc voltage that is required to maintain the arc during the welding and is usually 20 to 40 only, and is a function of arc length. So how much arc length you are keeping, that much is the voltage required. With MMW, the welder controls the arc length and therefore the arc voltage, which in turn controls the weld pool fluidity. So this when the welder will weld, how far, depending on how far he is from the steel, he will control that. He'll try, if he tries to maintain one electrode length or one electrode diameter length, then welding should go fine, and that is the what you call the thumb rule. So arc voltage too low, we saw current high and low. Let's see voltage too high and low. So if voltage is low, poor penetration, electrode stubbing, lack of fusion defects, potential arc strikes, in slag inclusion, almost the same thing as we saw in high current. So unstable arc, irregular weld bead, everything will happen. If the voltage is too high, there will be more spatter, porosity, arc wandering. What is arc wandering? Arc will go here and there, left or right. Then irregular weld bead shape, slag inclusion, fluid weld pool making positional welding difficult. So almost the issues are the same in the both of the issue. So let's see how the open circuit, how the welding, we said that we need drooping characteristic. So when we draw a graph of voltage to amperage, what we need is, we need drooping curve. So this is drooping, so it is falling like that curve we need. So what will happen when you do welding? You are between the blue light and red line, and black line is where you are supposed to be. So if you are doing welding, you are going either side, of this line, even if you go either side of this line, you can see that the current difference is very, very less, and that's what we need in this machine. So change in this voltage, arc length will not change much in the current amperage. Travel speed. Now travel speed is very important. Every welder has his own travel speed. That is what is most important in this. You see the first 5 items, travel speed was one of the important thing. So the rate of weld progression, the third factor that affects the heat input, and therefore metallurgical and mechanical reasons. Travel speed too fast, narrow, thin weld bead, fast cooling, slag inclusion, undercut, poor fusion, penetration. So if you do too fast welding, all this will happen. And if the travel speed is too slow, then you will have a cold lap. That means thick welding will happen. Excess weld deposition, that means very too much big weld bead will be made. Irregular bead shape will also happen, and undercut will be there because it is a very thick bead. Whenever there is a thick bead, undercut will surely be there. Now the next thing is very important, the polarity. Polarity will determine the distribution of heat energy at the welding arc. The preferred polarity of the MMW depends on primarily on the electrode being based, used and desired properties of the weld metal. So in manual metal arc or SMAW welding technique, the polarity is very, very important. Polarity will guide the welding quality, because sometimes what happens, it is required that the electrode be negative, sometimes the electrode requires to be positive, and many times because of the position also the polarity can be used, or sometimes usually the welder will change the or up or down the current based on what vertical uphill or vertical downhill he is welding. So these things are important, and that's why we are going to study this in a bit. So direct current is the flow of current in one direction, and for manual metal arc welding it is referring to the polarity of the electrode. So when we are always talking about DC positive or DC negative, we have to think about, we are talking about the polarity of the electrode. So we are talking about the electrode connected to positive terminal or negative terminal. That is what we are talking about. So let's see how it goes. So when the electrode is positive, the pole of, connected to the positive terminal of the welding circuit, the workpiece becomes negative. Naturally, it will become negative. Then, when the electrode is positively charged and the workpiece is negatively charged, the 2/3 of the available heat is at the tip of the electrode, with the remaining third being generated in the parent material, resulting in the increase in the weld penetration. So naturally, when the electrode is positive, more energy will be available, heat energy will be at the tip of the electrode. It is called as 2/3, and remaining will be in the workpiece. So with this, it will strike the arc and melt the electrode. What will happen if it is electrode is negative and workpiece is positive? When the electrode is on the negative connection, the workpiece becomes a positive pole. So electron flow direction is from electrode to the workpiece. Distribution of energy is now reversed. 1/3 of the available heat is generated at the tip of the electrode. Remaining 2/3 is in the parent material. So here things have reversed. So by experience, we need to see this, how it is useful in welding. So direct current with negatively charged electrode causes heat to build up on the electrode and increasing the electron melting rate and decreasing the depth of the welding penetration depth. So these are the things between positive and negative. So when using DC, the welding arc can be affected by arc flow, the deflection of arc from its normal path due to magnetic forces. So when you are doing welding, arc may wander, means go here and there. because of the magnetic forces. So it may be also become an arc flow issue. Let's see alternating current. So alternating current in the welding circuit flowing first in one direction and then other. With AC, the direction of the flow changes 100 to 120 times per second and then 50 to 60 cycles per second. AC is the flow of current in two directions. Everyone has seen the alternating current sine wave. A sine wave, when you, because if you see your tube light, it is going at 50 to 60 hertz per second. And if you do a slow motion video in your camera or mobile, and you can see the tube light is flickering. Why it is happening? Because instead of 160 cycle, your camera is now catching that in 30 cycles or 20 cycles. That's why the bulb will flicker at that frequency. Basically, your camera is trying to catch the tube light at the lower cycle per second speed. So if you understand this concept, then your alternating current philosophy, you will understand the AC current. So same thing, if that tube light is run on DC, the flickering will not happen. And that is why when we are making YouTube videos or whatever videos, they are using the light which is having, the battery power, then it will not happen because battery power is constant. But in AC, so talking about the welding current, the welding AC machines also can be used, and that is what it is saying here. The flow of current matters in this. So the type of, but it is very less AC machines are there, but you can still see them being used. So let us see at the coating, electrode coating. So the type of consumable electrodes, because there are not one type of coating, there are a lot of type of coatings. For manual metal arc welding, there are three type of generic coatings: rutile, basic, and cellulosic. So you need to remember all these three and what is their good benefits and what are their bad issues. So rutile electrodes contain a high proportion of titanium oxide, rutile in the coating. So titanium oxide is more, which promotes easy arc ignition, smooth arc operation, and low spatter. Obviously, if you use titanium oxide, obviously to your the arc ignition, smooth operation, everything will be very good. So these electrodes are general purpose with good welding characteristic, can be used with AC or DC power sources in all positions. Electrodes are especially suitable for welding fillet joint and horizontal vertical positions. So position matters. What are the features? Moderate weld metal mechanical properties, good bead profile produced through viscous slag, positional welding possible with fluid slag, and then easy removable of slag. So these are the features of that titanium dioxide rutile electrode. Come to basic electrodes now. Contain a high proportion of calcium carbonate. So that is what we saw in one of our thing that we described. Calcium carbonate is in the high, high in that. Then which is basically limestone, and calcium fluoride, which is fluorspar. So with using these two, they are using the making the covering of the electrode so that it is easy to burn off. So let's see ahead. So this, because of this coating, making of the slag coating more fluid than rutile coating, is also fast freezing, which assists welding in vertical and overhead position. These electrodes are used for welding medium and heavy section fabrication, and with higher weld quality, good mechanical properties, and resistance to cracking due to high restraint are required. So all this are the good things. This fast freezing assists in welding in vertical and overhead position, which is very important. These electrodes are used for welding medium and heavy section fabrication. So mostly everywhere you will see basic electrodes being used. And because they are very low hydrogen, so it's very good, important in industry to have low hydrogen electrodes. requires high welding current and speeds. Yes, it requires high current. Then poor bead profile. The bead profile will not be that great. Slag removal is a bit difficult, so that is you need to do some grinding or chipping hammer or something you need to keep. Let's see, cellulosic electrode contains high proportion of cellulose material in the coating and are characterized by deep penetrating arc, rapid burn off, giving high welding speed. Welding deposit can be coarse and with fluid slag. Deslagging can be difficult, so you need to use some grinder or something. These electrodes are easy to use in any position, are noted for their use in stovepipe welding technique. So there are some welding techniques which are helping these electrodes. What are the features? Deep penetration in all the positions, suitable vertical down welding, reasonably good mechanical properties, high level hydrogen generated, so the risk of HZ crashing because of the cellulose material will be there. So within these three generic groups, subgroup of electrodes provide a wide range of electrode choice. So this these electrode types will be decided by the welding engineer anyway, because there are so many things to see in this welding electrode, whether the position, whether the type of material that they are welding, the weather that they are in, everything matters here. So the welding engineer, based on that, will decide which electrodes to which coating should be used. So MMAW are designed to operate in AC and DC power sources. Although AC electrodes can be used on DC, not all DC electrodes can be used on AC power sources. This is very important characteristics, and that is why one need to read the uh, data sheet provided by the manufacturer of the electrodes. So operating factor, the percentage of arc time in a given time. When compared with semi-automatic welding machine, MMAW has very low this operating factor. As we have seen in the earlier chapter, the efficiency is poor. So efficiency is approximately 30%. Manual semi, because it is a lot of this activity is not having good productivity. All the lead managers I have seen, they don't like this process because of the productivity issues. Manual or semi-automatic MIG-MAG is about 60%. With fully automatic is in the region of 90 to 95%. Welding process, the highest is for SAW machine, which is almost efficiency is 1. So you need to know that it's very highly productive machine. Operating factor should not be confused with thermal duty cycle, which is safety value given as a percentage of time a conductor can carry the current, and given a specific current at 60 and 100% of the 10 minutes, 350 amperage 60% or 300 ampere 100%. So actually operating factor and duty cycle are different type of things, should not be mixed. Actually the safety duty cycle is when the time of when the machine is on, time when the machine is off. So that is a duty cycle. So operating factor of efficiency are different stuff. So that is what it is measured here. Summary of manual metal SMAW equipment requirement: transformer, rectifier, generator, inverter. So constant amperage type machine is good. So the machine will have a transformer which will have a rectifier also inside, and it will be inverting also. So this is what is a DC type of machine. Good power source. Power and power return cable, suitable amperage rating. So the cable that you will take or go to buy must have very good high current rating. Otherwise what will happen? It will become hot, and then it may also have frequent damages. Then also electrode holder. Electrode holder also must having a high amperage rating. Don't try to save money here because it is going to be hot, and then it will also damage very fast. So electrode also should be of a suitable rating, and also should be very good company. Correct visor, glass, safety clothing, and good extraction of fumes. All this is very important for welding. What about parameters and inspection points? Amperage, open circuit voltage, AC, DC and polarity, speed of travel, electrode type and diameter, duty cycles, electrode condition, connections, the connections that you are going to make on the machine and all that. Then insulation extraction. Insulations are the material which will make it hot, will not allow the heat to transfer. Then any special electrode treatment. So all these parameters and inspection points we need to remember. So typical weld imperfections now. Slag inclusion caused by poor welding technique. Slag is a very common issue. If they are not doing the inter-run cleaning, slag will remain in the welding and it will show up in the radiography. Porosity from using damp or damaged electrodes and when welding contaminated by unclean material. So we have seen that when you are using electrode, basically when we say when the wind is also there, the porosity comes, or if the electrode is not good also, porosity will come. So lack of root fusion penetration caused by incorrect setting of amperage, root gap or face width. So if your root gap is not good and if your face, the root face is not having the width, then there will be a lack of fusion and or lack of penetration. It also happens due to incorrect setting of the amperage. Then undercut caused by amperage too high for the position or for the poor welding technique. So undercut, as we said, that if the amperage is too high, undercut will come. Amperage too low, also undercut will come. So that is the reason. And travel speed, if it is too fast, these are the things which we already discussed earlier. So arc strike caused by incorrect striking procedure or lack of skill. We've seen arc strike both high current also, low current, low voltage. We have seen the arc strikes that was discussed earlier. So hydrogen cracks caused by use of incorrect electrode type or baking procedure, control of basic coated electrodes. So hydrogen cracks, why they come? Because if your procedure to control the electrode is not strong, then obviously the electrodes will not be good quality. Then on the fit up you will see some water or let's say grease or oil type, then things will get problem for the welding. Then also hydrogen cracks can come. Or we have seen there are three things which hydrogen cracks appear. If all that three things are together, then obviously it will come. There is also stress element there. If the fit up is in stress, your electrodes are damp, then two conditions are already there. So the third condition will be only the heating and cooling rate. So if you are not doing preheating and all, then obviously the hydrogen will be trapped in the electrode in the welding and then it will not come out easily. Successful welding with MMW process is reliant on number of factors, not of least which is skill required to produce a sound weld. This depends on the electrode's ability to match the arc length to burn off rate. So what happens is not only welder skill, that electrode welding with SMAW process, lot of things are there. So a lot of advantage and disadvantages is also there. What are the advantages? Field or shop, you can use it anywhere. Range of consumables that are very good. Then all position you can weld almost easily. Then very portable, you can have the smallest of machines in this. I've seen very small machines which are used for tack welding also. Then simple equipment is very simple, basic, starting, very cheap to buy online and start anywhere you want. But the disadvantage is that you need to practice a lot, high skill is required. Arc strikes, slag inclusion, these are the things which you need to worry about. Low operating factor, that means your job, if it is, you need to produce a lot of things, then obviously you cannot use this. High level of generated fumes, because since it's a coating electrode is there, it will have fumes, and also the hydrogen control you need to have on the job, otherwise you will get cracks. So that is about it, about the manual metal arc process. Let's see the slides. These are also very important exam point of view. Also, we have most of the slides we have already discussed. Especially this slide we have already discussed. Welding process. What is the objective? This is the objective. Why we choose MMAW welding. Main characteristic feature is shielding provided by decomposition of flux. Consumable electrode manual process. This is a manual process. Welder controls what? He controls arc length, angle of electrode, speed of travel, current settings. These are all welder will control. And this we already discussed the basic equipment. Then we discussed open circuit voltage. Then voltage, current, polarity, we discussed that. Which we said constant drooping characteristic. This is what we discussed. Then we discussed for DC positive, DC negative, and AC. All the three types. Then welding parameters, we discussed travel speed, we discussed parameter setting. So you can see the electrode weldings here is shown. One is shown as very good condition, and next is current is too low, then the current is too high, then the arc length is too short. These are the things which you need to observe on site. With this you cannot remember just like that, but you need to remember what will happen in various conditions. Then operating factor for manual metal arc, we discussed that it is a slow process, 30% only. Most caused by typical welding defects, how they occur. Then advantage and disadvantage we discussed just now. Then the consumables we discussed, how to use that. Then cellulosic and rutile electrodes we saw. So we also saw the basic electrodes. So we need to remember these two things very nicely. So this is what is the, we didn't discuss this BSEN 2560 MMA covered electrodes. So covered electrodes, there are certain notations to be followed. What will be that? So if you say we have say 7018 typical, so what will be that? So covered electrodes is F, yield strength. The next 2 digit is yield strength. The one digit is the toughness. Then the chemical, then there is like 2 Ni and all, you can see there is chemical composition in that. Then B is the flux recovery. So how to flux covering, what is the kind of basic coating or rutile coating. Then weld metal recovery and current type. So 7 belongs to that, current type and weld recovery. Welding position, 2 is welding position in this. H10 is the hydrogen content. So this is very important, whether it is H10 or whether it is H4. So you need to know that, because you have to select the low hydrogen electrode. So BSEN 2560 covered electrodes classifies E35, E38, E42, E46, E50. So these are the tensile strength minimum yield which is there for those electrodes. So here it is E50. That means it is minimum tensile is 500 Newton meters per millimeter square, and tensile strength is in the range of 560 to 720, which is a very high strength material. Then AWS, how they are doing is, they are doing F6018 or 6010 or 7018. So that is the covered electrode, and then tensile strength is given in 2 digit, welding position is given by 1 digit, and 3 is the flux covering type. And based on that, you have electrode. This is the type of electrodes that you have. So that's about it. We will start with another topic in the next. That will be, I think, TIG process. We'll go through the TIG section as well. Mostly it is in the forms of slides, and then we will come to FCW, GMAW. We need to stop here, otherwise this video will become too long. Then we will start with TIG process again.